So guys, today we are starting the topic differential calculus. So we get to know about the differential calculus. First we have to know about the limits, continuity and differentiability. So first let's dive in limits. The definition of limits is let f of x be a function defined on an interval that continues x is equal to a, except possible at x is equal to a. Then only we can say that limit x tends to a is f of x is equal to l. The meaning of that is when the meaning of that is f of x will be considered as a function, and for this function we have defined a interval that is x is equal to a. So to get the value of f of x, then we have to pull the value of x is equal to a. We have to pull the x value into a function that is f of x is equal to f of a. So similar it is. So get the limit of f of x, we have to do a limit function that is limit of x to a f of x is equal to l. So this is the condition, and in this we have two continuous, that is one is LHL and another one is RHL. The LH for LHL, the condition is f of x minus L is smaller than epsilon, and for RHL the condition is x minus a is greater than 0 and smaller than sigma. So let's dive in how we can solve this problem. So take an example and then we can understand about this. So here we have a example. Discuss the limit of the function f of x plus 10 at x is equal to 5. So the given we have f of x is equal to x plus 10, and another one is the value of x, that is 5. And by taking these value we have to find LHL and RHL. So for LHL and RHL, now we do the equation, that is first one is first we do LHL. So take for LHL first, what we have, the limit x tends to a plus, that is f of x is equal to L, and for RHL we have limit x tends to minus a, f of x is equal to L. So here f of x is nothing but f of x, and the L is x plus 10, and the value of x is 5 already we have. So let's solve this. Limit x tends to a, here already we have defined x is equal to a, so 5 plus 5 plus f of x is equal to x plus 10. So x is equal to 5, same it is 5 plus 10, that is 15. So limit x to 5 plus is 15. And another thing, and in RHL limit x tends to minus 5, f of x is equal to x plus 10, and the x value is here we have minus 5 plus 10, that is minus, here we have minus 5 and plus 10, that is the value of 15, same also, and behind of the bigger value, that is plus, so it is plus value. So the limit x tends to 5 minus is also 15. So here we get LHL is equal to RHL. So this contain hence the limit x is equal to x tends to 5, f of x is equal to 15. So hence proved. So now let's know about the continuity. The definition of continuity is a real function f of x is said to be continuous at a point c of its domain if limit x tends to c, f of x exists and equals to f of c. The meaning of this definition is nothing but about a function which is said to be at x is equal to c. A function f is said to be continuous at x is equal to c if there is are conditions. What are those conditions? First condition, f function of c, f of c have to be exist. And another one condition, f of limit x tends to c, f of x has to be exist. And third one, f of c and f of c is has to equal to limit of x tends to c, f of x. So these three condition has to be applied, then only it will said as continuity. To understand this concept, we have to solve an example. So here we have an example. Examine the continuity of the function f of x 2x square minus 1 at what point x is equal to 3. So here we have two given values, that is one is f of function f of x is equal to 2x square minus 1 and another one is the value x is equal to 3. So let's solve it is the function. So first we find f of c. So f of c is equal to f of c is equal to nothing but same, it is 2x square minus 1. What is the value of c? Here we have already mentioned that limit of x to c, f of x at point c. So the c x is equal to c. So here also f of 3. So f of 3 is equal to 2 of 3 square minus 1. What is the value of this? 3 square 9. 2 into 9 18 minus 1, that is 17. And another one we have to find, that is limit x tends to c, f of x. So for this same for value we have, that is 2x square minus 1. Let's solve it is limit x tends to c. What is c value? 3. F of x 2x square, same it is 3 minus 1. What is it is? It is 17, same as it is. So here we get the value, it is f of x is continuous at x is equal to 3. So hence it is proved. So next it is the differentiability. The definition of differentiability is a real function f of x is said to be differentiable at x is equal to a if f dash of a limit x tends to a, f of x minus f of a divided by x minus a exists. So for this we have some standard results to prove this. First we have to know about that. Here I have attached a screenshot about the all 15 formulas. You can see here. Here are all functions and productive rules. They are all available. As you know, just remember it. We can get to know about this in upcoming video.